All right, hello everybody. So welcome to the webinar, and as Pauline said, my name is Blair Layton. I've actually been with AWS for 4 years now, so I've seen quite a lot of change over the time, including with our relational database service, which we're going to go through today. The things that I expect to get over from this session are doing an overview of RDS very quickly, and then going through some of the different things that I think as a database person you should be doing on a day-to-day basis. So typically from AWS, when we're talking, we sometimes talk a lot about AWS terminology, about our service names with different acronyms, about things like regions, availability zones, etc. And when we're talking about our services, we tend to just talk about those particular services and the features they have. So what I'm trying to do in this session is go through the things that you would do on a daily basis. So if you're looking after databases, you would be concerned about security, about sizing them, scaling them, and so on. So that's what we're going to go through for the rest of the webinar. So RDS is a managed database service, and a lot of people say, well, I look after my database today. Why would I move to a managed database service? Well, if you think about your DBAs and your IT staff and where they're spending time, a lot of that could be on provisioning hardware and storage, doing installation, upgrading and patching software, having to document everything, especially around licensing, keeping up to date on training, and then the backup recovery, data loading, unloading data, and of course, security. So if you put that in a visual term, if you're doing this on premises today, you've got to look after everything from power and air conditioning network from the bottom, and then going up, doing your operating system installation, maintaining the operating system, then looking at doing the database install, database backups, and all the way up to application optimization. Now, if you were to bring this into EC2, a virtualization platform on Amazon Web Services, then we can provide all of the physical infrastructure and an operating system image, but then you would still be responsible for the security and managing that operating system and everything above that. When you come to a managed database service, such as RDS, then the idea here is that we'll be taking care of all of those particular requirements, and they allow you to concentrate on the application optimization. Now, what this means is that if you are looking at your competitors and if they have the same amount of resources, if you are focusing on the application and you don't have to worry about provisioning hardware, managing the hardware, doing the patches, doing the backups and the recovery, your staff can be concentrated on making your application stand out and be different from everybody else. So what we're trying to allow you to do is concentrate on making differentiated effort so that you can have a unique application or a unique experience for your customers. So RDS itself, what is it? Well, it is a managed service for relational databases. And the databases that we support are MySQL, SQL Server, Oracle Database, Postgres, MariaDB, and Amazon Aurora. Now, Amazon Aurora is our own database engine, if you like, that allows us to plug in other databases on top of it. So it supports MySQL today, and there's a preview for Postgres at the moment. Now, today I'm going to concentrate on RDS itself and not on Amazon Aurora. There's actually on the website that you probably looked at to register for this webinar, there is a recording of a talk I gave previously that goes into much more detail about Amazon Aurora. So if you want to know more about that, that's up on the website. So today is going to be more focused on RDS itself and the core capabilities there. So there are differences with Amazon Aurora, but I'm not going to call them out as I go through. So the idea with RDS is that it's a managed service to look after these particular databases and make it easier to do all those things we were talking about just before on the previous slides. So we do have customers all over the globe who are using RDS. Vodafone, for example, is using it to keep cricket scores and keep their customers up to date of what's going on in cricket around the world. Rovio, if you've played the games that they have, with Angry Birds, they're actually using RDS as part of their deployment for the Angry Birds games. And Airbnb, all of their main MySQL databases to support that business are running on RDS. And of course, there's many others here across different businesses who are using RDS. So let's get on to some of the core capabilities. Now, security, of course, is something that most people moving to the cloud have concerns about first. So let's get stuck into that. From a networking perspective, you want to make sure that you've got a secure network configuration. So when you create your account in AWS, when you want to go and deploy something, you have to deploy that into what's called a virtual private cloud. So this is a private network that if you create it and you put instances or servers inside this particular network, nobody will be able to get to that from the internet. You actually need to look at connectivity to get into your VPC. So this could be through another VPC that has a public interface, or it could be through a VPN connection that you set up from on-premise, or we have also what's called Aws Direct Connect, where you can set up a private line between perhaps a data center that you have or from your workplace into AWS. So that means that you're getting secure network connections to your particular environments. Now, if you did want to expose your application to the internet, then you can do that and set up appropriate privileges for specific subnets or specific instances even. On the database firewall access side of things, we can set up what are called security groups. Now, security groups can be set up for different people, for different IP address ranges, and also other security groups. So you can see in this example that we know what the corporate address is for where the administrators are going to come from, so we can open up access for those users to come into this particular network, or even this particular individual server. And then on the application tier, we know what the application security group is, so we can actually say anything running at the application tier has access to this database as well. So you can very finely grained set up access to this particular database, and of course make sure that only the right people have access to it. Then we also have to make sure that you've got governed access to RDS by user and role. So if you look at the bottom left, we've got applications accessing a database and the users and the DBA. That's controlled with database grants just as you would normally on-premise. So you've got your users and you allocate your roles and grants and so on. What we're actually talking about here is the RDS service itself. So the RDS service is going to control things like your rights to start a database instance, to reboot a database instance, or to even delete or remove a database instance. So you can, through our identity and access management, actually grant those to individual users. And that means you might have DBAs, for example, who have full permission to go in and create new databases, provision specific types of databases, for example, Oracle databases, SQL Server databases, etc. And then you may have somebody who's more of a developer, and they just need access to the dev test environments, and sometimes they're doing some crazy things, so they would like to perhaps reboot the server. So you could just give them access to a particular server and say that you have rights to reboot that. So you can do very, very fine-grained access from a user perspective as well. Now, in transit, all of our 6 engines that we have support network encryption in transit. And you can set this up using typically the default mechanisms that are available for each of the database engines. And we've also made it on some of the engines where you can stipulate that this must be mandatory. So, for example, a customer in Australia in the banking insurance industry wanted to make sure that any connection to their RDS Postgres database was secure. Otherwise, they would have to actually audit and record all of the connections. So we introduced that feature for Postgres where you could actually say, okay, I want this to be only accepting SSL connections. And that alleviated a lot of the auditing demand for that particular customer and other customers as well. At rest encryption. So there's 2 different types of encryptions that people look at from a database perspective when they're looking at storage on disks. The first is just to encrypt the file system. And this is what we offer from an RDS perspective. So you can say, for this particular RDS instance, we want to have all of the storage encrypted. And then that means that any of the backups and read replicas associated with that and the snapshots that you create, which we'll talk about a bit later, will also be encrypted. Now, there's no additional cost for this, and that's great at supporting compliance and security that you need. Now, the other example, if you're coming from a SQL Server or Oracle background, is transparent data encryption. So transparent data encryption is in the database itself, where it is encrypting the information before it gets to the disk. So if, for example, if you were actually access to a server and you were on that server, you would actually be able to see the database files unencrypted because you have rights on that server to look at the files. But if you're using transparent data encryption, when you went to look at those data files, you would actually see that some of the columns or table spaces, etc., are encrypted, so you wouldn't be able to see that information in relatively clear text. So that's the key difference between the two types of encryption that is available. From a compliance perspective, AWS is very, very concerned about making sure that our customers can comply with different authorities across the world. So you can see FedRAMP is something that is very US specific, but it incorporates a number of different risk management programs. So from that, a lot of people overseas, when they see that, can know that they can trust what is happening on a particular environment. Then you've got things like PCI DSS for doing the storage of credit card and financial information. And then you've got even a Singapore-specific security and compliance grant, the Singapore MTCS. So if you look at this across the different engines, you can see that there's quite a good story. Now, the gaps that you see, for example, on SQL Server, where there's no HIPAA compliance at this point in time, these are things that we're actively working on, and we hope to fill out this table so that we get ticks across all of the boxes. So what you can know is when you're looking up this information, it's available on the website, that if you need to comply with any of these particular authorities or standards, then you can get this information on our public website and validate that you're going to be able to do that with RDS. So looking at sizing on RDS. Sizing in the cloud is a bit different. Typically on-premise, of course, you would go for something bigger than perhaps what you need because you're looking at perhaps a 3 or 5 year timeline for the hardware. So when you're looking at RDS instances, the key thing is that you should really size for what you need today, because it's quite easy to resize that if you get it wrong. The concepts are similar to what you would do on-prem. So we talk about our instances in terms of vCPUs or virtual CPUs. Now, on all of our modern instances, these are hyper-threaded cores on Intel CPUs, and we can go from 1 up to 40 vCPUs on RDS today. Now, with the RAM, we can go up from about 1 gigabit to 244, so that's about almost 256 gigabytes of RAM. And then on network throughput, we can go up to 10,000 megabits per second. And then we have this concept of an Ebs Dedicated Network. Now, EBS is our storage, which I'm going to go through shortly, and this allows you to have a direct line to storage to give you more consistency rather than to be contending with perhaps large reports that are getting pulled out from the database, and that network is getting very busy and possibly even saturated. So the EBS Dedicated Network throughput is very important to know, and we document these on our documentation for each of these server types as well. Now, in terms of the storage and how much you can have on RDS, you can now have up to 16 terabytes, and that's on SQL Server only at the moment, but the other engines are 6 terabytes, and we hope to get there towards the end of the year. Now, as I mentioned, Aurora, we've just mentioned a couple of things as we go through, that does use a separate storage service, so do be aware that you probably have heard that that is 64 terabytes. So there's different engines do have different capabilities. So what is EBS? It is a network block storage as a service. The EBS volumes attach to any Amazon EC2 instance in the same availability zone, and it's designed for 5 nines of availability with 5 types of storage. Now on RDS, there are 3 types of storage that we have on offer. Excuse me. The first one is magnetic. Now this is the original storage that was available for EBS, and it is based on magnetic drives. The next one that we commonly recommend for customers to use for most workloads these days is general purpose, which is SSD backed. And then we have our very high-end storage, which is Provision IOPS, and that's also SSD based. So the general purpose SSD has a very interesting concept. And this graph hopefully will allow us to go through and make you understand what's happening. So if you have a volume that is less than 1 terabyte, you can actually get more than what your allocated baseline for IOPS are. So for every gigabyte, you get 3 IOPS. So that means if it's 500 gig drive, then you have 1500 IOPS. But what you'll be able to do is burst up to 3000 IOPS. So if you have a workload that is bursty, but it only does that every so often, you will be able to use general purpose and take advantage of this bursting capability. It works in a bucket concept. So for every I/O that you are not using as part of your baseline, that goes into the bucket. And then when you go above your baseline, we start moving the IOPS out of that bucket until the bucket is empty, and then it will gracefully move down to the baseline IOPS again. So what you don't want to do is to get this sizing wrong for a production system, because what can happen is that if you empty the bucket, then the performance is going to degrade quite severely, and your user is going to complain. So you do need to take into account what is your I/O profile, and what is the actual baseline that is good for you, and then what is the reaction and over time of that bucket. Now you can monitor it and make sure that you're checking that and seeing when it's getting emptied and when you are having no problem at all. The other thing is that it is cheaper to over-provision the general purpose to get the level of provision IOPS that you need. So you may find, for example, that you see, well, I only need 100 gigabytes of storage, but I need a lot more IOPS. Perhaps I should use provision IOPS. That's valid, that you have a much steeper up ramp on provision IOPS to get the IOPS that you need for the allocated storage, but you may be better off just allocating more general purpose and getting using the burst-in capability and even a higher level of baseline. So let's have a look at provision IOPS. As I mentioned, it's a higher ramp up, so it's a 50-to-1 ratio. So for a 100 gig drive, you get 5,000 IOPS as a maximum, and then any volume that has more than 400 gigabytes allows you up to the maximum of 20,000 IOPS per volume. And I must mention also that on the general purpose on the previous slide, the maximum IOPS per volume is 10,000. So you also have to take into account throughput limitations, and that depends on block size and how many IOPS. So for example here, if you're looking at the block size of 256K for each IOP, then the maximum throughput is 320 megabits per second, but your IOPS are going to be limited at 1,280, even though you can actually do 20,000 IOPS with a smaller block size. So you do need to take these types of calculations into account. And here's a summary of the different types of storage. So you can see in terms of some of the sizing, the magnetic can only go up to 1 terabyte, but it starts smaller than, say, the provision IOPS, where you have to start at 4 gigabytes. The IOPS for the magnetic is pretty much based on what you would expect for a magnetic drive, including the throughput. Then if you look at the SSD-based side of things, then you can see that the throughput is much higher. The maximum number of IOPS on a given instance is higher, as is the throughput. And then the pricing is appropriate for the different levels that you're looking at. So if you've got a dev test instance and you're just not concerned about the performance of it, you can definitely save some money by using magnetic. But we generally recommend that you use general purpose SSD. So do choose your instance wisely. We've seen this a number of times where people do not understand the integration between a virtual CPU and how much I/O that can drive, the amount of RAM that's needed to minimize read level access to I/O, and then setting up the network. And as you can see, just from a sample size here of the M4 instances, that a M4 large has moderate network performance, and it does have a provisioned or EBS optimized access. But you may find that even though the number of vCPUs and the memory is adequate, you might need a bigger instance to get to the high network performance for the level of IOPS that you need to drive. So do look at these types of calculations and work out what is the right size for you. Now, a good thing is that if you are on-premise today or you're somewhere else and you can access the metrics, you should be able to work out what is it that you actually need today from your existing environment. Now, if that's older hardware, let's say you've got 3 to 5 year old hardware on-premise and you're looking to move a database into RDS, then you can have some leeway there for perhaps using less resources, because on AWS you'll be using higher throughput in terms of perhaps network. The storage may be magnetic on-prem, it may be SSD on AWS, so you have to take into account some of those things. However, the beauty of this is that if you do get it wrong, it is quite easy to change, and we'll show you how to do that later. So this is scaling. Now, if you're looking at on-premise and you need to resize your database instance, let's say your boss comes along and says, look, we're going to do a marketing promotion, we didn't expect this was going to happen, and now we're going to have to resize this database to take on the extra load. Well, on-prem, you are going to have to order new hardware. You're going to have to work out a plan of how you're going to get that hardware provisioned, then work out how you're going to migrate from your existing infrastructure across to the new infrastructure, manage all of that, and of course that becomes a major project in itself. With RDS, we allow you to scale up or down, and you can use this to manage the case that we're just talking about, where you want higher load or perhaps even lower usage. And another mechanism is to control costs, just by right sizing. If you find that you got the sizing wrong from the previous slides we were talking about, it doesn't matter. You can actually get it right and then change it on the fly. So all you need to go into is the management console for RDS. There's a drop-down menu for instance actions. You click on modify, then you get a list of things that you can modify for that particular engine. And on the DB instance class, you get a drop-down list of all the different instances that you can use. So you could simply go in here, and at the moment it's on a DB M4 large with 2 vCPUs and 8 GB of RAM. And then if you wanted to double that, you could just choose an M4 extra large, and that will give you 4 virtual CPUs and then 16 gigs of RAM. So once you've done that, at the bottom of the page, there's a little tick you need to apply called Apply Immediately, and then you hit OK, and the system will go ahead and do all of the resizing for you. Now, if you're using a highly available environment that we have called multi-AZ, then this will actually occur with a failover as part of the process. So the overall process will only take about 20 to 30 minutes to complete, but the application itself will only see downtime of about 60 to 90 seconds. So that's a huge improvement and greater flexibility to be able to do that compared with on-prem. You can also scale reads with read replicas for MySQL, MariaDB, Postgres, and Aurora. Not only can you do read replicas in the same availability zone or data center, you can also do it across our region. So in this example, you can see a master database running in, say, Oregon, and then read replicas in Virginia, Japan, and Sydney. So this allows you to perhaps get information closer to your users so that they get better response times, and it takes a load off of your master database so that that can concentrate on writes. Now, read replicas for Oracle Database and SQL Server. We do support Oracle Golden Gate for RDS Oracle, so if you're fortunate enough to have licenses for that, you can use those. We also support the AWS Database Migration Service, which I'm going to talk about later, and that acts as essentially a replication server to allow you to replicate to other databases or to Oracle and SQL Server. You can also do third-party replication products. And then lazy man's one is you could create regular snapshots, and if the data is reasonably static, set up read replicas based on those. So looking at backup and recovery. The way RDS works is when you create a new instance, you specify a maintenance window to do patching, and you also specify a backup window. The backup window, it happens every day, and you would typically choose, say, a half-hour block in the evening or early morning or something like that. And what will happen is that every day we will do a daily snapshot using incremental snapshots. And these are by default for 7 days, but you can increase or decrease those. And you can increase it up to 35-day retentions. And the other thing that we do in terms of automatic backups is all the archiving of the database logs are sent to S3 every 5 minutes. So this allows you to recover to any point in time by taking the daily backup and then applying the logs that have been saved to S3 forward to the point in time that you need to recover. There's also multiple copies in each availability zone where you have instances for a deployment. So if you do need to restore an instance, you do need to be aware that it does create a new database instance with a new endpoint. So you will have to reconfigure your applications, or perhaps if you've got a CNAME set up, you would need to change the CNAME to point to the new RDS instance when you do a restoration. The way that you go through and define everything is just like creating a new instance. So you do need to specify exactly what type of instance you're restoring, the security groups, and all those types of things as well. Now you can see down the bottom here that there is 2 options. You can restore to the latest restorable time, which is where we've saved all the data, and it's the maximum retention, if you like, or that would maximum recovery point that we're going to get. But you can also do a custom restore time. So this is where you can specify that, hey, a DBA accidentally ran a script in production and they removed a whole heap of MySQL data and tables. We need to restore the database to exactly that point in time before that script was run. So you can specify that there and then create a new instance restoring all of the data. You can also create user snapshots. So the snapshots, as we were talking about before, are done automatically. These are done by yourself. You initiate them. And this is great because you can set these up to do things like when you want to do application upgrades and you want to make sure that you've got a copy of everything just before the application was going to be upgraded. So then these go into S3 as well. And again, you can create a new RDS instance from that. They also remain encrypted if you're using encryption. So you know that these snapshots are going to be secure when they're put into your account. So the use cases for using snapshots. Resolving production issues. If you need to get a copy of the production database, you simply do the snapshot, create a new instance, and you've got the production data in a new database that's now on a separate instance that you can play with and work out what's going on. You can create dev test environments. Perhaps you could create a standard snapshot for dev test, and then you could create new databases and destroy them as you see fit as you're doing your testing. You can also do the point-in-time restore that we talked about. When you're going to terminate a database, then what we will ask you is, are you absolutely sure, and do you want to create a final snapshot as part of that process? So there's actually a couple of steps you have to do to terminate and delete an RDS instance. So there's a bit of protection in that process. You can also use snapshots for disaster recovery. So because they're going into S3, which is a regional service, if, say, you have a single node running in a particular AZ and then we have an outage on that AZ, what we will then do is be able to say, okay, let's recover a new instance into the other availability zone based on the snapshot that's been created from the previous backup, and then, of course, roll that forward with the logs as well. You can also do cross-region copy and copy between accounts. So, for example, if you had a production account and a dev test account, you can take snapshots and move them between those accounts. And then for really good DR, let's say you're running in Sydney today and you want to make sure that if something did happen in terms of a massive disaster in the Sydney region, then you could copy your snapshots up to, say, Singapore, Japan, or even to the US, and then that would allow you to recreate your environment in those other regions if something from a disaster perspective did happen. So talking of disaster recovery, we kind of covered off most of it in that session, but we're definitely going to look at high availability. So if you're going to deploy into AWS, and I've mentioned availability zones and regions a little bit, so let's just go through and make sure everyone's clear on this. A region is a self-contained service, if you like, or series of services that AWS provides. In that region, we will have a number of availability zones. Now, those availability zones, you can think of them as data centers. So in this particular diagram here, you can see that there's a region, let's say it's Sydney, and there's a single availability zone, and inside that there's a network with a master database and an EBS volume attached to it. So this would be a single AZ deployment. Now, if something was to go wrong with this particular environment, then let's say the availability zone disappeared, then you would have to do a manual restoration. You would have to go and do what we were talking about before, taking a snapshot and restoring that into another availability zone. So for many business applications, that's not good enough. And what we recommend for production workloads is to run multi-AZ. So here you can see again a single region, and then we've got two availability zones. We have a master database running in one, and then a standby or running in another availability zone. Now, the networking between these availability zones is typically less than a couple of milliseconds, which allows us to do synchronous replication. So what that means is that anything that's committed on the master is guaranteed to be committed on the standby before you get the acknowledgement back to your application. So this allows you to have confidence that if something did go wrong in the main availability zone, whether it was just a hardware failure or a storage failure, or the whole availability zone became unavailable for, say, networking issues, then we will actually fail over to the standby database. So how that works is that if you are having your users and your applications connecting to the database through a particular DNS entry, and that will be pointing to the master. So if something goes wrong with the master, what will then happen is that we will recognize that there's been some kind of outage and propagate the change to the DNS to then point to the standby node. Now, this takes approximately 60 to 90 seconds. And that varies depending on detection time and DNS propagation time. And then, of course, it is also dependent on recovery. So if you are running a massive batch job on your database and it was just about to finish, let's say it was a payroll run, and you hadn't committed all the changes, then we would, of course, need to undo all of those changes to restore to a consistent point as part of the database recovery when that standby node is coming up. But in terms of the AWS capabilities and moving the database over and making that available, then it would be roughly in that 60 to 90 second time frame. So metrics and monitoring. Inside AWS, we have a product called Amazon CloudWatch, and we provide a number of metrics to that particular service. And that includes things like CPU utilization, storage information, including I/O, read and write, number of database connections, and so on. Then you can also set up alarms around this. So for example, if you're constantly seeing CPU above 70%, then you can set an alarm on that to trigger you to go and have a look at what's happening there. Now, we also introduced enhanced monitoring. So this is access to over 50 new different metrics, including even process lists running on the instance. So some of the feedback we had from customers is that RDS is a managed service, it's a bit of a black box. I would like to see more information about what's going on in the actual system. So now, not only do we have many more metrics that can allow you to look at what's going on the operating system level, we also have lowered the interval. So on the standard metrics that you get from most AWS services these days, it is around 5 minutes, and then you can pay a bit extra to get down to 1 minute. But with RDS, it was the first service to introduce going down to 1 second intervals. Now, I must stress, don't turn this on for everything that you have, because it will generate a lot of activity and you will have to pay for the associated data that's being captured and stored. So what I suggest is, especially if you're doing a new deployment or doing an upgrade, a patching of your application, or doing a load test, and you need to, say use New Relic and get alignment of all the problems that are happening through all the tiers, then that would be an appropriate time to turn this on and make sure that you're getting the right granularity and down to 1 second even. And you can set that if you like, 5 seconds, 10 seconds, etc. It's really up to you in terms of what level of granularity that you want. You can also do event subscription through the simple notification service, and this can notify you when things happen. So for example, if you want to keep track of when availability issues occur or when someone deletes RDS instances, you can set up notifications for that, and then you subscribe to that particular notification and do actions based on it as well. So perhaps you may want to send an email or some kind of notification to tell you what's actually happened. There are also support for native and third-party tools. So if you want to look at Oracle Enterprise Manager and use that as a single pane of glass for on-premise as well as in the cloud, then RDS does support running Oracle Enterprise Manager on RDS. For SQL Server, you've got the Management Studio as well. And then there's third-party tools that you can extract data from the CloudWatch metrics and integrate as well, such as New Relic, Toad, Datadog, WebYog, and Navicat. And there's actually more as well. Also on the integration tools side of things, if you want to use something like an ETL tool or a data replication tool, then we do support Talend, Informatica, Attunity, etc. So there's quite a good ecosystem of the native support as well as third-party tools that do integrate with RDS. So looking at migrating to RDS, if you are looking at the name of this service, it can be misleading. So let's make sure that we understand what you need to use for what purpose. So the AWS Database Migration Service sounds like it does all the database migration activity that you would do, but it does really what's called data migration, not necessarily the schema. So we'll talk about two tools. The first one is AWS DMS, or the Database Migration Service, and another one, the Schema Conversion Tool. So DMS is all about moving data from one database to another with minimal downtime. So it uses change data capture technology to allow you to migrate a database while it's actually running, the application is running on it, and then once you've caught up, you can migrate and switch your users across to the new target platform. This works both from on-premise to AWS and from AWS back to on-premise. So as long as there's AWS somewhere in the picture, we support the movement of data between these particular databases. We also recently introduced support for NoSQL. So MongoDB as a source and being able to target that data to DynamoDB or to RDS is something that was added back in, I think it was April. So you can now also move data from relational systems to DynamoDB as a target. So you can change your technologies from relational to NoSQL. Now here's the schema conversion tool that we talked about briefly just before. So you actually have to run the schema conversion tool first to get the database schema changed, especially if you're doing a heterogeneous migration, say from Oracle to Amazon Aurora. And that way you're going to be going from an Oracle database to a MySQL database, so you need to change data types, the schema definitions, you need to convert stored procedures from PL/SQL to MySQL's code. Excuse me. So you need to go through and do a whole series of operations before you can actually use the database migration service to map the data from the source to the target. So this is a great tool to do these schema migrations. It also supports migrating data warehouses to Amazon Redshift, including the extraction of the data from those databases. Now let's go into licensing on RDS. First of all, a disclaimer. So the information in this session is just to be used as guidance for licensing purposes. Sorry, must not be used as guidance. It's really informational and non-binding because all the licensing decisions must be agreed with you and Microsoft and Oracle. You also must review your Microsoft PER and your Oracle license agreement to understand your specific usage rights. And the reason for that is that each of these agreements is often customized, especially for large enterprise customers. So essentially, you can say, well, don't believe anything I'm about to say, and please check with Microsoft and Oracle, but I'm here to help give you a little bit of information that will help you along the way. So some licensing terms first. Bring your own license. This is where you bring licenses that you already have according to the portability rules of your vendor. License included. So this is where we provide, as AWS, the license as part of an hourly instance fee. Dedicated instances, these are instances where the underlying physical hardware is not shared, and a dedicated host is a dedicated AWS physical server that's allocated to you. Then we have virtual cores, which are directly mapped to physical CPU cores, and virtual CPUs, which are hyper-threaded virtual cores on the new hardware, and on the old hardware like M1s, M2s, they are simply just mapped to cores because there's no hyper-threading there. So SQL Server license mobility on AWS. This is information that you can actually look at and on our public website, and it goes through how you can use license mobility through AWS. So if you have software assurance, you can actually use the licenses that you have and bring those to AWS. Now, there are guidelines in terms of the instance types and the number of licenses that you need, the minimums, etc., and that's again published on the website. The key point is the second paragraph here towards the bottom, where it says a virtual core is defined as the unit of processing power in a virtual hardware system. A virtual core is the virtual representation of one or more hardware threads. So what this unfortunately means is that Microsoft is saying that you have to license hyperthreads, not physical cores, in an AWS or cloud environment. So if we look at how you can do the licensing on RDS, there are a few key versions: 2008 R2, 2012, 2014, and 2016. You can actually get license included with Express Edition, Web Edition, Standard Edition, and Enterprise Edition. For Bring Your Own License, where you need the software assurance, then that's available for Standard Edition and Enterprise Edition. So for fleet migrations, we would actually recommend that you use EC2 dedicated hosts. And this is to obtain similar licensing costs to on-premise and similar conditions as well. So for example, on RDS, if you wanted to use an R3 8X large, which is the largest RDS instance for the highest amount of memory, then that would be 32 licenses on RDS. However, if you use an EC2 dedicated host, which is going to give you the capability to launch an R3 8X large instance, you only have to license the 20 physical cores of that physical server. So you're losing a little bit in the sense that you're going to lose some of the cores to DOM0. You're only going to be able to access 16 physical cores, but it's still cheaper than licensing for 32 licenses compared to that 20. From an Oracle perspective, you can bring all your Oracle licenses across to AWS. I've got a little asterisk on the ULA, and you can see why if you open that document and go searching for it, it does say you're allowed to deploy any licenses you have under an unlimited license agreement, but at the certification period, anything deployed in the cloud is not going to be included. So that would actually mean you would have to repurchase licenses that are deployed to cloud environments. So that's a pretty nasty limitation there. In terms of the way Oracle is licensing on AWS, for Standard Edition, so that's Standard Edition, Standard Edition 1, Standard Edition 2, is all licensed by sockets. So they count every 4 virtual CPUs as a socket. Therefore, if you have 6 virtual CPUs, you need to round that up, and that would be 2 sockets. For Enterprise Edition on hyper-threaded virtual instances, you need 2 vCPUs to make 1 processor license. And then for the non-hyper-threaded instances, it's 1 license per vCPU. So what Oracle is basically stating here, again, is that they are doubling the cost of deploying on AWS and Microsoft Azure as well, where typically it would be for x86 platform, they would use the core factor of 0.5, allowing you to have 2 physical cores per Oracle license, whereas here we're looking at a single physical core per Oracle license. So if we look at the versions available for Oracle Database, it's 11G R2, 11204, and 12C 12102. Now there's various versions of each of those that are deployed on RDS with the different patch set levels. So you can look at what you need in terms of which patch sets and deploy the appropriate version from that. We do offer license included by the hour for Standard Edition 1 and Standard Edition 2. And we also allow you to bring all your licenses in for Standard Edition 1, Standard Edition 2, Standard Edition, and Enterprise Edition. So Oracle changed its licensing policy to reflect what was on the previous slide, that is essentially doubling the cost in January. There are ways that you may be able to address costs of licensing on AWS, and we highly recommend that you work with third-party licensing specialists such as Palisade Compliance. They do have representatives in Asia Pacific to confirm your Oracle licensing requirements on AWS. RDS, Standard Edition 1, the licensing follows the original metrics. That is, it is essentially on the old metrics. So RDS has not changed the licensing terms for Standard Edition 1. Cost management on RDS. So if you've got everything running and you're concerned about how you're going to lower costs, we have introduced a great new feature called Stop Start. So if you have development and test instances, you can stop them down and start them up when you need them. Now, what that means is you could say 8 p.m., everyone's going to be gone, so we're going to stop everything, and then we're going to start everything up again at 8 a.m. Now, this is going to be a big cost saver, especially if you're using the license included instances, because you're not going to be paying for that license component while the instances are stopped. What you do pay for is the storage. So the storage is still there, you'll still be paying for that, but the instance cost is typically much higher than that. You can right size and scale up and down, and it'll be demonstrated it's really easy to change the instance sizes so that you don't over provision like you do on-prem. And then choosing the right storage. Provision IOPS is great for performance, as I mentioned, but it costs a lot, so you need to provision more than general purpose to get a lower cost overall if you need the IOPS. And choose the right edition. No, you don't need Oracle Enterprise Edition or even SQL Server Enterprise Edition for everything. Use the cheaper versions, and that will help you save time. And then buy our reserved instances. So reserved instances are a commitment from you to use a particular instance for a period of time, and then we offer a significant discount on that. Since databases are on practically all the time, then it makes sense to buy RIs. So looking at an RDS compatibility matrix, this is a summary of all of the core features across the RDS engines. So if we look at where there are differences, and I mentioned this at the start, right? that storage is different across the different engines. So there's 64 terabytes on Aurora, and then across all the Linux-based engines, we have 6 terabytes. Now we're hoping to get those all up to 16 terabytes by the end of the year, in line with where SQL Server is now. And SQL Server just increased theirs to 16 terabytes last week. So if you didn't know about that, that is something that's just happened recently. Now, scale storage. You can see that Aurora is auto-scaling, and then all the Linux ones do have the capability to scale storage. So what do we mean by that? If you want to provision more storage, it's an operation that can happen while your system is running. So let's say you're on 1 terabyte and then you'd like to allocate another terabyte. We will do that in the background and keep the database running, and then there'll be a small outage as we switch across to the new storage. SQL Server does not have that capability at the moment. Again, we're hoping, on this diagram here to fill in all the gaps and make everything consistent across the platform over time. In terms of IOPS, we can go up to 30,000 on most of the engines. Again, SQL Server has a difference. They can go up to 20,000 at the moment. On the instance sizes, the largest instances in terms of RAM to compute are the R3 family, the R3 8XL, which has got 32 virtual CPUs and 256 gigs of RAM. And then the largest in terms of compute is the M4 series, which has 40 virtual CPUs. So that gives you a summary of the core capabilities across all the different engines. If you want to look at other relational database options, EC2 allows you to install any database that runs on Microsoft Windows or Linux, and you can use EC2 when RDS doesn't support a feature or there's a limit such as the 6 terabyte storage limit. So if you need more than that, you can simply deploy, say, Oracle to EC2 and allocate more storage. Maybe you need 10 terabytes or something like that. So that's easy to do as well. And then on the marketplace, which I'm showing there on the right, you can go and search for relational databases or other databases if you care, and find all sorts of open source pre-built environments and commercial environments as well. And some of them include licensing for commercial databases, so you can get a price. As you can see, there's Informatica Cloud for Amazon RDS there. So you've got integration tools and those types of things that you can get and purchase.